Welcome to Ask and Learn.
This problem, we have a beam cantilevered at the left end, and then it's angled at the right end, and there's a load applied at a 30-degree angle or a minus 30-degree angle with the horizontal, and then another load applied at a distance of, let's see here, 4 meters from the cantilevered end. So to solve these problems, really you just need to write some vectors out, and I'll kind of go through or systematically solve them through the rest of this chapter. And write force vectors and position vectors to those force vectors. So we have, I call it F1, the external load. So that's has a negative 6 kilonewtons in the horizontal and the vertical direction. F4 or F2 is this 4 kilonewton load, and so it has a magnitude of 4 kilonewtons and a direction of cosine of 30 degrees in the x and minus 30 degrees in the y. The position of this is 1.5 meters from the cantilevered end. And the position of this one I broke into 2 parts, this position vector and then this one. So we have 3 in the horizontal direction, and then 1.5 times cosine of 30 in the x direction and sine of 30 in the y. And then I put zeros here. Again, because when we take the cross products, actually we need to consider the third dimension. So if we balance forces in the vertical direction, this plus this, and then have our reaction forces, so we get this equation. Some forces in the x direction, and we get this. And some moments, we have a moment here, and this is actually a positive moment would be in the counterclockwise direction if this is x and this is x and this is y. So we have minus m plus r1 cross f1 plus r2 cross f2, and that has to be 0. So this gives us 3 equations. There will be one non-trivial component to this equation. So we have 3 equations and 3 unknowns, and we get that v is minus 8 kilonewtons, n is minus 3.46 kilonewtons, and m is 20.2 kilonewton meters.